Last May, NASA announced that the James Webb Space Telescope had discovered the most distant galaxy ever observed in the universe. This is groundbreaking for the science of astronomy and cosmology. But how is it determined to be the most distant galaxy? Let's take a brief look at the significance of this discovery and why this galaxy is the most distant galaxy we know of, as well as how the distance of an object in the universe is determined. The James Webb Space Telescope Advanced Deep Extragalactic Survey, or JADES for short, has so far discovered hundreds of galaxies. Many of these discoveries have been quite extraordinary. But this galaxy is certainly the most interesting. This galaxy has been named JADES GS Z14-0. The name is a bit long, so let's call it Z14 for short. In fact, NASA has just announced this discovery, but the Webb telescope has been taking images from it since the beginning of 2023. With this discovery, Webb also broke its own record. Because Webb had previously detected a galaxy 325 million years after the Big Bang. However, according to Webb astronomers' research with a lot of data, Webb's images of that formed a galaxy 290 million years after the Big Bang. This makes it the earliest galaxy ever observed. But this is not the final state of the galaxy, only the rays that reach us make it look like this. This is still in its early stages. And why is that? Because after the Big Bang, electromagnetic radiation was emitted everywhere in the expanding universe. Our universe has been expanding for 13.8 billion years. Therefore, the cosmic rays we see anywhere in the universe right now are actually the electromagnetic remnants of the Big Bang. As a result, we are witnessing only 2% of the total age of Z14. That's because more than 13 billion years have passed since this 290 million year old image. So Z the 14th of May have disappeared long before our 4.5 billion year old Earth even existed. But even if Z14 disappeared long before we could detect it, how can we see it? Or rather, if it exists, why are we seeing the galaxy as it was at least 13.5 billion years ago and not as it is now? Our universe is huge and is constantly expanding. Therefore, the first objects to form are naturally far away from where we are. And they're moving away from us at a faster and faster rate. And we are moving away from them. But we occupy such a small space in the universe that we can't perceive these effects directly. At this point, light provides us with a very important reference for understanding the universe. In order to see anything in space directly, either it or other things around it must emit light. Objects that don't emit light are hard to see. That's why we can't directly observe dark matter and dark energy, which make up most of the universe, as we can objects that emit light. Being able to see an object in space depends on what the object is, how much light it emits, the electromagnetic nature of the light, the technology we use, the distance of the object, and whether there are any tertiary obstructions between us and the object. For example, the rays of the sun, which is 150 million kilometers away from the Earth, reach the Earth in only 8 minutes. So when we are actually on Earth, we see the sun as it was 8 minutes ago. If the sun suddenly disappears now, we will realize it 8 minutes later. Another example is Proxima Centauri. Proxima Centauri is the closest star to us, located outside our solar system. It takes more than 4 years for the rays emitted from Proxima Centauri to reach Earth. In short, when we look at it, we see it as it was years ago. In this case, we are actually looking not at the current state of things we see, but at the past state of things. Moreover, thanks to the James Webb Space Telescope, we can look back billions of years into the universe. Considering the size of the universe, stars like the Sun are actually very close to us. The farther away stars and galaxies are from us, the harder it is to observe them and measure their distances. So, how do scientists know that this galaxy is the farthest away? Or let's put it this way, how do we determine how far away objects in the universe are? Some scientific methods such as the Hubble constant, the parallax method or the cosmic microwave background radiation are used to solve this issue. However, in this video we will try to understand it in its simplest form without going into such detailed and complicated things. In short, astronomers use various methods to determine distances in the universe. At the heart of most of these is the redshift method. Redshift is when the wavelength of an object's light gets longer and redder as it moves away from us. Our universe has been constantly expanding since the Big Bang. As the universe expands, the wavelength of light from galaxies far away becomes longer and redshifted in the electromagnetic spectrum until it reaches us. So, by measuring the amount of redshift of an object, we can calculate how far away it is from us. For example, the redshift of the Z14 galaxy discovered by Webb was calculated to be 14.32. The opposite of this method is also useful. That is, the blue shift method. The shorter the distance of objects in the universe, the shorter the wavelength of their light, and hence the bluer the color. The trick is the electromagnetic wavelength of light. Estimating such vast distances is, of course, beyond human perceptual abilities. So, we have to use the most advanced computers, telescopes, and of course mathematics to understand the distances of the universe. Because the universe is so vast that it is almost impossible to imagine it with our limited perception. The Z14 galaxy observed by Webb was also detected at redshift. But when you look carefully at the image, the color tones in this bean-like shape look very different. This is because the Z14 galaxy is just the area inside the circle. The lighter shaded area at the top is actually another galaxy that is closer, which is why it appears less red-shifted and coincidentally appears side by side with the Z14 galaxy. However, the image gives us another important detail. And that is that Z14 looks very bright despite its great distance. Normally, galaxies this far away don't have such a high luminosity. Moreover, the brightest galaxies usually get most of their light from gas falling into a supermassive black hole. But Webb's measurements show that the brightness in the Z14 galaxy, which is more than 1,600 light-years across, is produced by young stars. So, the universe appears to have created a massive galaxy in less than 300 million years. And all this can be known thanks to the James Webb Space Telescope. Scientists say that if this bright galaxy had 10 times less light, we could still have discovered it. This means that we could also discover galaxies that formed much earlier in the universe. So, the James Webb Space Telescope could beat its own record by discovering even more distant galaxies. What makes Webb different in making these incredible discoveries? The James Webb Space Telescope is the most advanced space telescope ever built, developed and operated by NASA, the European Space Agency and the Canadian Space Agency. The $10 billion telescope was sent into space in 2021 as a joint effort. Thanks to its ability to observe in infrared light, Webb can see very distant and ancient objects through clouds of dust and gas. This allows it to observe objects that the Hubble Space Telescope can't see. The James Webb Space Telescope, with its 6.5-meter-wide primary mirror and sensitive infrared instruments, has already made this historic discovery. As a result, with such discoveries and the spectacular views it captures of the universe, the James Webb Space Telescope is enabling the study of the most distant galaxies in the universe and shedding light on big cosmological questions such as the Big Bang and the expansion of the universe. This information deepens our understanding of how the universe began, how it is expanding, and what path it will take in the future. If you are interested in interesting discoveries, facts about our universe, nature and history, don't forget to subscribe to our channel and turn on notifications. See you in the next video.